Here is extremely important question based on inverse trigonometric functions. Master strategies for solving inverse trigonometric functions. Here is an exam practice review which can help all grade 12 students. So we have trigonometric equation which needs to be solved without graphing calculator. A equals to tan inverse 1 over 3 minus tan inverse of 2. Find the value of A. In your YouTube channel, you have playlists with well organized videos on inverse trigonometric functions. Explore, learn, and master these strategies. Now let's take up the solution of the given problem. Now, since we need to find the value of A, how about taking tan on both the sides, right? So we'll begin by writing as tan A equals to tan of all this, which is tan inverse of 1 over 3 minus tan inverse of 2. Now, tan inverse of 1 over 3 is an angle, right? And tan inverse of 2 is also an angle. So let us say that these angles are alpha and beta. So we can write this as alpha minus beta, right? So we have tan of alpha minus beta with us. We can now expand it, find the value of alpha and beta, substitute and get the answer. Do you see the strategy which we can adopt here, right? So applying the compound angle formula, we can write this as tan alpha minus tan beta over 1 plus tan alpha beta, right? Perfect. What is alpha and beta? That is what you need to figure out. Well, fortunately for us, we are working with tan inverse 1 over 3 and tan inverse of 2. Both are positive in quadrant 1, that is correct. So let's make the triangles. For 1 over 3, we know the opposite side should be 1 and the adjacent 3. We have the angle alpha, which is 1 over 3. Makes sense. And for tan inverse of 2, the angle beta will be like the opposite side will be 2, adjacent 1, right? And we have our angle beta. So that is how we can actually sketch the diagram. Now clearly from here, tan alpha is 1 over 3 and tan beta is 2. And therefore, we can write down these values here. We have tan alpha as 1 over 3 minus 2 over 1 plus 1 over 3 times 2. Makes sense, right? And now we can find the value of tan A. So tan A is equal to 1 over 3 minus 2 plus 1 over 2 over 3, right? Let's multiply by 3 both the sides. So we get 1 minus 6 over multiplying the denominator by 3, we get 3 plus 2, which is minus 5 over plus 5. So we have a value of tan A as equal to minus 1. Now tan A being negative 1, inverse of tan A is in quadrant 3 and 4, right? Using the cost rule, we get our solution, which is this, correct? So we have two solutions for tan A equals to minus 1. Makes sense, right? So those should be the solution for this particular equation since we are looking at the two angles. You should also remember that arc tan is actually defined within first and the fourth quadrant, correct? From minus pi by 2 to plus pi by 2. And therefore, in this particular case, what should be our answer? Well, the answer should be minus pi by 4. So it's kind of important to understand that tan function, inverse of tan function, is only valid in quadrant 1 and in 4. And therefore, we'll write down A as equal to minus pi by 4. So that becomes the answer for this particular question. I hope this concept is absolutely clear. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. All our students are getting admission to the best universities, some with scholarship also. Thank you and all the best.